Okay, everybody, welcome to this second online roadshow event of the AACOMA Utrecht project, where the topic of today will be about the possibilities of advanced composite manufacturing. As you can see, this effort and this roadshow event, online roadshow event, due to the circumstances, is made possible by a lot of different parties. And for you all, for you audience, we have a 3-day agenda where today we have first and for all a small introduction to Flanders Make, the host of today. I'm also part of Flanders Make. Secondly, made by Maarten, a research fellow of Flanders Make. Secondly, Bernard will give a short presentation and an overview about the AACOMA project. What are the deliverables? What type of why did Europe invest in the cross-border collaboration of Germany, Holland, and Netherlands and Belgium on composite materials? And then finally, the longer presentation of today is a joint presentation by Dr. Michael Effing from AMAC and Dr. Elmar Witten from AVK, both German organizations. And they have done an analysis about the composite market. So what has been the evolution of the last couple of years on composites, more structural usage and things like that, but also very important and very interesting, I believe. What is the impact of COVID-19 and on the market and the situation of composites in general? Please note this is a 3-day event, so also for tomorrow we have some very interesting speakers, very expert speakers from CIRIS, talking about the various innovative methodologies and manufacturing technologies of composite materials, but also, of course, once we have the materials manufactured, how to assemble them by usage of adhesive bonding. Jeroen van Kastreff of Flanders Make will give a presentation on this. Tomorrow as well, I believe we have a very interesting online matchmaking event where we will work with poll questions. So you'll have an idea about what type of companies are present. So we have a few poll questions seeking out what kind of industries we have present in the matchmaking event. And then we'll also present you some questions so you can learn what are the bottlenecks, what are the drivers of people to adopt composite materials. So I think it will be very informative. And then finally, we have also a kind of an introduction course to composite materials, again, presented by CIRIS next week, Tuesday on the 9th of September. Just for meeting hygiene and before giving the word to Maarten of Flanders Make, please all mute your mic. We will handle all of your questions at the Q&A at the end of the presentations. So if you have a question, don't hesitate, just put them in the chat. I will monitor the chat, bundle the questions, and then present the questions back to the presenters at the end of their presentation. That's it from my side. So let's start with the first presentation by Dr. Maarten Witters on the competences of Flanders Make on, for instance, composite materials.
Thank you, Manuel, for your kind introduction. Okay, you can now see my screen, and I will give a brief introduction to Flanders Make, who we are, followed by a virtual tour about the research results we have been achieving and the infrastructure we have available for research in doing on composite manufacturing. We as Flanders Make are a strategic research center in Flanders, and our research is driven by 3 market trends. First, we see that products are getting more and more smart and interconnected, as well as their production systems, of which the complexity is raising also. Second important trend is that products are getting more customized, made to your specific needs, but you don't want to pay more for it than a regular product which is produced in series. And thirdly, sustainability is increasingly important, and the human in production systems role should be preserved, and its well-being has to be guaranteed at all times. So these are the triggers for us to do research, and we do specifically research with the aim to boost the long-term competitiveness of high-tech companies in Flanders and abroad, and to drive them to innovate their products and production systems to meet these challenges. The researchers of Flanders Make are about 650 specialized people, and they are spread all over Flanders. We have 4 co-creation sites focused on vehicles, drones, production systems, and machinery. And the 5 Flemish universities are associated, meaning that certain research groups are strategically aligned with the roadmap of Flanders Make. Together, we do research in 4 competences. First one is decision and control, to increase intelligence in systems, in products and production systems. The second track is on design and optimization, is to speed up design processes to make them more multidisciplinary and to facilitate an exchange of information in order to cope with complex design problems and product variability. The third research track is called motion products and has to do with making drivetrain systems, whether they are for vehicles, machines, or flying objects, to make them more energy efficient, to make them more performant, but also to make them more autonomous. And this requires drastic changes in their system architectures. The last research track is about flexible assembly, in order to facilitate the creation of flexible production system in which robotics, digitization, automation, and operators go hand in hand to create a flexible environment where easy reconfiguration is facilitated. Specifically for the AACOMA project, the research team of the circular joining technology is involved. They're working in the joining and materials lab located in Lommel. So in this lab, we have a set of core competences we are developing. First one is with respect to the selection and design of joints for multi-material products, where we have expertise in design and selection of adhesives, but also expertise in modeling these systems and evaluating performance. The second core expertise is to test and to validate the designed products and their production systems. Thirdly, in order to make the production systems, we want to deploy Industry 4.0 technologies with respect to automation, robotics, digitization, and to support operators in these production environments. And that's then also the fourth expertise. It's preparing for Industry 4.0. It is capturing data about the product over their entire life cycle, and also during production, to gather these data in a structured way and to deploy them to retrieve predictive actions to improve production settings and to improve the product performances. The joining and materials infrastructure is unique. It offers the possibility to prototype products, advanced products, multi-material products, and their production systems. So we have equipment that covers the entire production chain of multi-material joint products, going from commoditization to surface treatments to application of adhesives, curing, and finally the testing. And in this equipment, we deploy, where possible, robots and cobots. We have dedicated equipment to test the final functionality of the performances of a product in climatized conditions and under dynamic conditions. And during this whole process, we capture data in order to monitor product performances and production system performances. In the following video, you will see some examples of activities of our labs towards production and improvement of composite products.
Maarten?
Yes.
The audio is not coming through yet.
Okay, a second. Apologies. Should be better now.
Flanders Make is the strategic research center for the manufacturing industry.
We look at industrial problems and we analyze them, break them down into engineering practices. We really offer the end-to-end chain from software engineering and modeling all the way into product validation, product testing to help the industry.
One of the key research domains is composite materials.
Because they offer great stiffness for a low weight ratio. This makes a lot of applications very interesting. Think about fuel efficiency in industries like automotive and aerospace.
After often starting on paper, designs are quickly transformed into computer models.
And what we are doing specifically in Flanders Make is try to develop simplified modelings thanks to optimization techniques, and with that getting results in a much lower time frame that are accurate and that can be applied to the full-scale model. For a single joint application that we have tested in a component level, we can reduce the simulation time from 15 minutes to 15 seconds with our methods and our optimization algorithms.
Once a composite part is in production, handling it can prove quite challenging.
Machining composites is a complex process because of the nature of composite panels themselves. They are formed by fibers that can easily delaminate.
Delamination is a serious threat to quality in the aerospace industry, where large panels need to be joined together.
We are speaking here about panels that can go in the order of magnitudes of 20 meters long and with 5 millimeter thickness, very thin. Machining this kind of composite panels is very complex because they need to be stabilized.
Currently, this requires large and costly fixtures. Flanders Make has patented a handy add-on solution called Smart Clamp.
The results we achieve with Smart Clamp is reduction of delamination. In some applications we reach more than 70% improvement in quality.
Another way of joining composite parts is by using adhesives. Due to their interesting properties, they're able to withstand vibrations and completely seal the assembly.
And this is where we come in as joining a materials lab. So in our lab, we have all the necessary testing facilities to map the right process parameters for the adhesive bonding process. So we have a climate room where we can control the temperature and humidity conditions, and we can test and manipulate parts that are as large as 1.5 meters in size.
Extensive research enables the Joining and Materials Lab to vastly accelerate the curing and bonding process, among other things.
We try to make them debondable by not changing much of the chemistry of the adhesive, but just changing the process parameters and try to have special particles or additives inside the adhesive so that we can debond it with external stimuli like electricity, for example, or magnetic fields.
Ranging from virtual product optimization, from various assembly mechanisms to full product testing, Flanders Make offers a broad set of innovative facilities and competencies to boost applications with composite materials.
So if companies have a question about composite materials or need expertise, they can always go to our website, flandersmake.be, for more information.
So that was it for me. If there's any question, I would like to pass the word to the next speaker, Bernard Paquet, who will introduce you to the AACOMA project.
So, hello, do you hear me?
Yes.
Yes, and do you see my presentation?
Yes.
Okay, thank you for introducing me. I will speak you about the new AACOMA project that started this year in 2020. The content of the presentation will show you the context of the project implementation, the objectives of the project. I will present you shortly the partners and then also speak about foreseen and ongoing activities of the project. So starting with what is a composite material? It's a physical combination of two or more materials to produce a combination of a structural material with properties that are not present in any individual component. So that means that you have to combine fibers, filaments, a matrix of thermoplastics or thermoset, and you need also to design and engineer the all together to produce a composite. That means various fibers, various matrix types, and various combinations and design gives you a large variety of composite materials. Some properties of composite materials are surely the high strength to weight ratio that leads to fuel savings in sectors like automotive or aeronautic and transport, or to reduce the inertia of pieces and reduce the stress by fast moving parts, for example, in the energy sector for windmills. Tailored reinforcements are possible following requirements so that you can adapt mechanical properties. You can also achieve smooth and free shapes that give you a big flexibility for designing parts. It's also possible to design complex shapes and they can be produced by added manufacturing. So complex shapes can reduce the part counts and cost reduction in assembling. Composites offers also excellent resistance to corrosion, chemical attack, and outdoor weathering, so that you can have a high durability of your product and reduce also the maintenance cost. So these are some of interesting properties that can be used in any sectors. In the last decades, mainly the aeronautic sector used most of composites. And today, modern airplanes has until 50% of material in composites. But other sectors can be used, use materials of composites, and so that gives an opportunity for many sectors. So why this project is to innovate material design and advanced manufacturing of composites and to provide large opportunities for SMEs, mainly from any sectors. New materials such composites can make their way to a wide range of sectors, and we constated a general need of knowledge about composites is awaited by companies. So this project will also minimize risk for SMEs before investing in expertise, skills, human resources, demonstrations, and testing. Opportunity for company is evident because we try to accelerate the use of composite material for product innovations. Companies can implement innovative manufacturing technologies and materials and also use sustainable composite materials. So the objectives are clear. It is to accelerate advanced manufacturing of composites. We will do that by communication and strong networking. showing proof of concepts and inspiring companies for new projects after this one. So by this objective, we will promote the Région Meuse-Rhin as a hotspot for composite manufacturing. The project AACOMA has a total budget of nearly 3 million euros, and 50% are funded by the Interreg program Région Meuse-Rhin. And we obtain also co-financing from regional authorities. So the consortium is composed of partners from the Région Meuse-Rhin. At first is Flanders Make, the strategic research center for the manufacturing industry situated in Lommel in Belgium. Then we have the Fontys University of Applied Science in Eindhoven. We have the Institute of Bio-Based Materials at the University of Maastricht, situated in Rilin. The AMAC company is an industrial and business consulting company in the field of lightweight construction materials situated in Aachen. Then we have also the Department of Aerospace Mechanical Engineering of the University of Liège in Belgium. We have the Technologic Research Center with the Product Hub Development Department series in Belgium. And also, at least, Centexbel, it's a competence center for textile and plastics, and we are in charge of the lead of this project. The planet activities are making awareness to composites, then involving companies in the project, developing generic demonstrator, and have also sustainability action for the future of composites in the Région Meuse-Rhin. Making awareness of composites to companies, we will do that through a strong network of composite manufacturing companies in the Région Meuse-Rhin. A who is who database will be set up with manufacturers, stakeholders, institutes, organizations, so that everybody can see who is available in the Région Meuse-Rhin and is in relation with composite materials. And we try to capture the attention of multi-sectoral manufacturing companies. We will do that through roadshows, network events, and trainings. Today we have the second roadshow started here by Flanders Make in Lommel. I will attract attention for other events that will take place this year. Is a training foreseen about basics of composites. It will be organized the 9/12. And in early next year, we will have the AACOMA public kick-off event that will be organized the 25 February. Probably this will also be a virtual event. So who is who? The creation of a common database of the composite community will reinforce networking, and we will build up a living community of companies, institutes, universities, organizations. So this is a possibility to make you visible in the AACOMA, on the AACOMA website, to be visible to the composite community. Therefore, you can contact our communication responsible, Mona Ziegler. Involving companies, we create an industrial advisory committee. We organize matchmaking organization to identify also the needs of you all in composite manufacturing. We try to develop concept for demonstrators, and we will organize training sessions. Already we started with the constitution of a top-class advisory board for the AACOMA project. The aim of the advisory board is advising the consortium for innovations and action with real needs of today's and tomorrow's industry in the EM area. This advisory committee is open to any company, so if you want to join the advisory board as a member, please contact us. Networking and matchmaking will be organized to exchange about challenges in manufacturing community, to explore also the future needs of this committee, and to implement adapted workshops and trainings with a focus on your needs. Here are some expressed opinions from the last matchmaking that we organized in September. In this matchmaking, most of participants come from the automotive industry, and new applications are expected mainly in this sector actually. Composite processes expectations are mainly for new processes and new materials. The composite materials are mainly expected, main expectations are for circular materials and recyclability. And in the domain of design and engineering, the main interest is for virtual engineering and Industry 4.0 implementations. So we are also starting to develop a series of demonstrators. The aim is to address some technology challenges, to make a proof of concept that we will show through these demonstrators, to make an evaluation of these demonstrators, and to disseminate finally the learned lessons about. We target 5 thematics for this demonstrator. One will be in relation with graphene-based composite materials, one with hybrid yarns for new manufacturing processes. One will touch on composite repair, one for biomaterials, and the last one will target robotics and cobotics in composite manufacturing. So also these demonstrators, you can give us your advice and your opinions about. Then the last point will be sustainability actions for the future. Therefore, we will set up guidelines for advanced manufacturing of composites and inspiring you for follow-up projects with companies or between companies and institutes. So I come to the end. We will soon implement the AACOMA website. It is foreseen to have it online in the next week. I will give you here a first impression of what it will look. So here you have an overview of the AACOMA website. The aim is that we will keep in contact with you, that you can inform you about the project progress. You will be informed about the innovations made by demonstrators. You will have the possibility to to be part of the who is who in the Eurasian. So therefore, please contact us so that we can add your company here in this database and to make you visible so that you can show your own activities, but you can also find companies of interest for cooperation in future projects. Then you can have a look here on the advisory board that is actually started. And finally, you have also access to training activities and events and news that are ongoing in the AACOMA project. Here I will end now my presentation. I thank you for your attention and I'm open for further questions. Thank you.
There are no questions in the chat, so I assume it was very clear then. We will now have the next presenters. It's a joint presentation with Michael Effing of AMAC and Dr. Elmar Witten. So it will be more about the market perspective, what happened last year, what are the latest, let's say, trends in the composite world.
Yeah, good morning to everyone. I think you can see my screen. Is it correct? Please confirm.
Yes.
Yes. All right.
We can see your screen.
Very good. Yeah, so my name is Michael Effing. I'm located here in Aachen, as you might see in my background. I am the managing director of the company AMAC, which is since 2012 here in Aachen on the campus of the university. I'm also in several functions in terms of the trade associations in Germany. I'm the chairman of the board of the German association AVK and also Composite Germany. And on this behalf, I have asked our managing director, Elmar Witten, to give the latest market updates, which we just published a few days ago about 2020, year 2020, as well as talking about the impact of the COVID-19 crisis. So today in my presentation, I will talk about, of course, a little bit linked to Bernard Paquet on the AACOMA projects, what we are doing and what we have in mind. But then the main point is in talking about the composite trends or trend in the composite industry, specifically on the automotive, which is very important, certainly for the German market here, talking about the lessons learned from this really star project of the BMW i3 and where we are going in the future. Then I will hand over to Elmar Witten. He will talk about the European market by application, by technology and by region. And then he will pass back the word to me and we'll talk about the numbers, initial numbers of the COVID crisis and the outlook for and we have Q&As. We can have Q&As not only at the end, but even after my first part of the presentation, after the trends, I will stop. So please ask your questions or go into the chat functions and put them there. And then, of course, we will talk with Elmar Witten after his presentation about the European market. When you have questions to this topic, maybe you can address them already there. And then, of course, we do the last one all together. So first of all, composites. Most of you know the world of composites, but in order to have the right definition, what I like to highlight here is we have normally a fiber material, we have a matrix material, and we have different structures of the material. Normally we talk about carbon and glass fibers, but also in our AACOMA project we have here natural fibers involved. We have also basalt fibers on one specific application for electromagnetic shielding. We have, of course, the traditional aramid or even Dyneema fibers involved in that. And on the matrix materials, mainly we are focusing on thermoset and thermoplastics. But then, of course, it's a question of what do we count for composite materials. So we are starting from the short fiber. So that's basically injection molding, talking about maybe 3-4 millimeters of long fibers. Then longer fibers like LFT, GMT, and going to continuous fibers and different laminates thereof. And with composites, this is an anisotropic material. You have not only the lightweight as a function, but also corrosion resistance, electromagnetic shielding, maybe and other possibilities as well. So I think Bernard Paquet highlighted already the objective of our project. So important for me is that we highlight that the area around the 3-country corner between Germany, Netherlands, and Aachen is a hotspot for composites, hotspot also for electromobility, and also a hotspot for automotive. We had a similar project in Interreg Lightweight 2025, which is going to a completion by the mid of next year. Even in e-mobility, not only with the street scooter in Aachen and the Ego Mobile, but with also a lot of suppliers to this industry in the Netherlands and Belgium. We have here a hotspot also for the automotive segment, and I'm very pleased that also Ford here is part of our advisory board, Ford here in Aachen and Cologne. So we are targeting multi-material systems. We are targeting to connect all the SMEs to the world-class universities and institutes here and to the research centers that we have here in the region. And for most of you, it's maybe obvious, but for a lot of people, it's not obvious that it's difficult to work across borders. As a maybe traditional, let's say, a German company, you would look first for in Germany, go maybe 5-6 kilometers away and find a tool maker which we want to use, but maybe the tool maker could be just across the border within a few minutes. And that's what we try to achieve, that we are connecting really across borders. So the main activities, I think Bernard has mentioned them already. I think we want to show how we work together, and we are doing this by working on generic demonstrators, and we have identified already the top 5 priorities for us, which you have seen. Important is also, again, here composites in general. It's a top technology and top industry for Europe, especially for high-wage countries. There is a lot of funding going on, not only in Germany with the University of Technology in Aachen, but also around us. That this is a technology that should not move away to Asia or other parts. So I think it's very important that we try to find, let's say, processes, technology, and know-how that stays within Europe, within our region, and can be defended because of the level of automation, the level of, let's say, know-how and complexity that we can handle here, and that makes us maybe different to other parts of the world. So Europe and the Euregio here is a hotspot. We will have also soon the European, not soon, but in 2024 in Maastricht, the big event on composites, the ECCM coming up here. And we have events every day around us at the different campus of the universities. So it's a key technology for economic growth. You can say that composites are growing normally with 1.5 times the GDP of a country, specifically because we are replacing metal. So, and we are in many industries, in markets, so it's an important growth technology, and it's also important for innovation and high performance. It should allow mass production, and I will highlight today a couple of processes that really allow cost-effective automated mass production. And I will also indicate how energy and resources can be, let's say, reduced. CO2 footprint can be reduced by using composites. And last but not least, we want to maintain and also bring new workplaces to Europe that are sustainable and are high quality. And that's also not only the aim of this project, but also of the trade associations that we are dealing with, like the AACOMA or Composites Germany. So let me talk about now in my next part here in terms of trends in the automotive industry, and I'm taking the example here of the lessons learned from the BMW project. So for most of us in 2012, the project on the i3 was really the hype for the composite market, specifically also the word carbon composite market triggered a lot in the industry. So you know this module, this car, the i3 produced in Leipzig, Germany, has a so-called live module completely out of carbon fiber composites. and the drive module, the bottom part with the batteries, everything is completely made with aluminum. So it's really a full solution on the composite part. And the company BMW and the family Quant behind that really made a big effort to bring everything in-house, starting from recruiting 500 of the top experts from the industry and confirm and transform them into automotive experts. So they have recruited from the aerospace industry, from the materials industry, and many others, and put them really into the automotive environment, developing all the technologies that are needed to make this module. And maybe before I go there and describing the steps, maybe just highlighting what has happened there. So BMW decided to have the carbon fiber production in-house, implemented in North America, in Washington State, making the carbon fiber. Then the carbon fiber weaving and pre-breaking was done in Germany near Landshut, and the final manufacturing and construction was done in the Leipzig plant, which is a brand new plant that has been built there, and was then completely integrated in the full assembly process of making the BMW i3 work. So the behind the story was really the effort to show, okay, weight savings can be need to be realized, because the model was in conventional model would have been 1,380 kilograms, and by using carbon fiber material it was possible to reduce the weight by 30%. The batteries alone, I think, will weigh more than 500 kilogram on this car, so there was a need to show lightweight. So by using 30% of the weight, that leads also to a significant CO2 reduction, and also a significant reduction in consumption of fuel. So more than 3,000 liters less in terms of fuel throughout the life cycle of a car. And in terms of the CO2 footprint reduction, so in production 20 tons, and maybe during the whole life cycle 50 tons of CO2 could be reduced. And that was, of course, an important story to document what the composites can do for automotive. The life module then was made in basically thermoset processes using RTM parts, lithic RTM and wet pressing process, so not super sophisticated processes like you might imagine, but let's say processes that were, let's say, controllable. 34 parts were made and molded and glued and assembled together. And this has been, I think, a great effort of the industry, and was really done on time. The good news is also the build rate of cars. Initially, they started to have maybe 20,000 per year, and in the first 2 years it was maybe difficult to get. But the build rate is now up to more than 40,000 due to all the additional funding that is going on. And also the good news is that BMW decided to extend this model until the year 2024. So it will be a 12-year life cycle for this vehicle. So initially, people were questioning in terms of maybe the cost. But I think it's has shown BMW being a leader for electrical composite vehicles. Of course, there were issues. There were issues in terms of waste. Normally, for 20,000 units per year, there's 1,000 tons of carbon fiber waste that has to be recycled. And there was a recycling stream developed by BMW and several companies, chemical companies, like in the nonwovens market as well as in the plastic market. So it can be completely reused in a different form, but it can be reduced. Of course, the cost of carbon fiber has not come down as expected, and it will not come down because it's just depending on the high cost of the precursor, etc. So that is definitely there. And of course, the reproducibility to produce day in, day out, winter and summer, different, let's say, climates, a good product that has been a challenge. So what were the lessons learned from this project? I think there is a need for cost-efficient materials. There is a need for more cost-efficient processes. There should be no scrap or minimum scrap, so we cannot just trim off material that is expensive. processes have to be very robust, day in, day out, and of course recycling is needed and cycle times of a few minutes to be needed. So I think in terms of the learnings from BMW is they will continue with carbon composites in cars, but more for high-end cars. Actually, the new BMW 7 Series has more composites in a car than the i3. The total volume of the BMW 7 Series is already more than 100,000 units per year. So the consumption by the 7 Series of carbon fiber composites is higher than on the i3. But BMW is, of course, looking also into more multi-material systems, and it's also favoring a lot of thermoplastic materials in the future. So we'll see the next generation. I think it will be a hybrid solution between metals, composites, and composites with maybe glass fibers and maybe more thermoplastic that we have seen. But still, lightweight is the way to go, and there is no question that composites have to be used. In terms of further cost reduction, different people were looking into this. There was already a study made many years ago by Roland Berger, and the main point is really that this industry is a very fragmented industry with a lot of steps, process steps in between that is adding cost. Therefore, BMW brought everything in-house, that you are not adding margin by margin from one company to the next company, but you make basically the fiber in-house and the textile products in-house and the finished part. And the main, let's say, discussion is that in the production methods, a lot of cost saving is possible through automation, through, let's say, near net shape preforms, etc., where in maybe the field of glass fibers or also the resin, it will be very difficult because the prices are very much down already. These are high volume parts of millions of tons per year, like glass fiber, for example, and there's a certain level. On the carbon fiber, there was an reduction, let's say, expected by another 15 to 25%, which did not happen because there is not enough capacity on carbon fiber for high end, and therefore I think the aerospace grades and the windmill grades are selling at a higher price, and so we don't expect significant reduction on carbon fiber in the short term. But out of that, in discussion with the automotive industry, four most promising manufacturing technologies were highlighted that will be investigated more, and you will see them more in future vehicles. One is, of course, the hybrid thermoplastic composites, then high-speed RTM, high-performance SMC, maybe together with carbon fiber use, and then the filament winding of pressure vessels like the pressure vessels for hydrogen, maybe in thermoset initially and maybe thermoplastic in the future. And I just want to highlight maybe with one slide each what we mean by that. So I think very, let's say, fast growing is the, from a smaller base, of course, is the hybrid thermoplastic composite market, where you can have maybe organo sheets or tapes and have them as an insert in the molding process. So it can be over molded, it can be combined with LFT or GMT. I think this is a way to go. And we had just yesterday a webinar together with one of a German supplier of organo sheets, Profol in Eastern Germany, who has invested 20 million euros in a new production line for this technology. So this is coming from a smaller base, but this is definitely a growing. Ford Focus, the door was here a good example. Another thing is the high-speed RTM. So this is basically the production line that is installed at BMW in Leipzig. So that will be optimized with preform handling, automation, etc., and less scrap and faster resin. So that's another route to go. SMC, all the major SMC producers are working with a high-performance SMC using at least a portion of carbon fiber or even carbon fiber waste, etc., in it, and bring this back to back. And last but not least, pressure vessels. So this could be the so-called killer application in the market. So the carbon fiber production for pressure vessels has to be increased a lot if things are coming through. We had in one of our interregular projects here, also across borders, the company Plastic Omnium in Belgium and AMS and a few other companies involved. And just the forecast is if only 2% of the vehicles by the year 2030 will be fuel cell driven fuel cell driven vehicles, and they need pressure vessels with hydrogen. It has to be carbon fiber. Then today's carbon fiber production has to be tripled just to overcome that. So that's a big challenge. There was a big announcement also by Plastic Omnium that they will go this way and will be the market leader in the future. So this is definitely a technology today in thermoset, which might also be open for thermoplastic in the future. So these are my let's say extracts and trends from the composite industry, mainly for automotive. So I'm not sure, Manuel or whoever looks at the questions, do we have any questions so far?
No, we don't have any questions in the chat.
No question, okay.
Sorry, my microphone was still bended. No, we don't have any questions in the chat yet, but maybe someone of the audience would like to ask a question at this moment, if there's an opportunity.
Yeah, if not, I see my colleague Elmar Witten. Elmar Witten is the managing director of the AVK, the oldest trade association, founded in the 20s in Germany, so almost 100 years old. The AVK is publishing market reports about application technology and region. And maybe I'll give the word to Elmar to give the latest report to the audience here.
Yes, okay. Thank you very much, Michael. So if you handle my slides, it will not be possible that I need too much time because Michael is switching from slide to slide. Can you start with the first one, please? I still see.
One second.
Does it work?
Does not go on.
It works. Okay, whatever we did. So I cannot go on mute, so I will be silent.
Okay, thank you very much. As Michael already said, just a few additional words on our organization, the AVK. The AVK is the Federation for Reinforced Plastics in Germany. It does not mean that we are an organization only for German companies, but we are focusing on the German market. We have around 230 member companies of the whole value chain of composites, and 1/5 of the companies are not German companies, and we even have 7 Dutch companies as members. And the contacts in our member companies are around 1,700 people. We have the main pillar of our organization is our so-called expert task forces, which are meeting regularly and where we meet people and where we build this strong network. As Michael already said, there's another umbrella organization of the composites industry in Germany. It's called Composites Germany. And Michael and me, we are also in the lead in this organization. We are together in this organization with the VDMA, that are the machinery producers in Germany, and with other composites organizations. I'm also a member of the board of the European Composites Industry Association, so to have a network with our colleagues in the other composite countries in Europe, and we are in the board, Michael and me, of the umbrella organization of the plastics converters industry in Germany. So just a few words to our organization, but what I would like to tell you a little more in detail is about the trends and the development of the GRP market. So GRP is the glass fiber reinforced plastics segment of the composites industry. Michael already showed you some very interesting trends in the industry, mostly driven, or some of them driven by carbon fibers for high-end applications. But we do not have to forget that most of the material in the market, so in terms of volume, it's 95%, is reinforced with glass. So the carbon fiber market in total is around 1% of the whole composites markets. So we are talking about 10 to 12 million tons of composites materials produced worldwide, and the amount of carbon fiber reinforced plastics is around 100 to 150,000 tons. So 1%, and 95% of the material, composites material, is made of glass fiber. And if we have a look at the development in Europe, we make this survey for the production of glass fiber reinforced plastics in Europe since decades from the AVK. And you see a development which is increasing and decreasing. I will come to the sources for that later. But what we see in 2020, and mainly due to the Corona crisis, is a decrease in the amount of the production of glass fiber reinforced plastics in Europe of around 10 to 12%. So the total amount of the production is 1 million tons of material. But that is really, as Michael already said, the market is very fragmented. So this number alone doesn't say too much, because we have a different development in each of the countries in Europe. We have a different development in each of the material classes that are used and in each of the applications. But what we can see if we compare our number, the next figure, please. If we compare the development of the GRP production, this is the green line in this table, to the general economic development, so the real gross domestic product in the EU countries, that is the blue line, or the industrial production in the EU countries, that is the red line, we see that the GRP production is in line with a general economic development. And that is maybe not surprising, because the main application areas for using composite material, and especially using glass fiber reinforced plastics, are the transport sector and the construction sector, each with nearly 1/3 of the amount. That means if the construction sector is declining in Europe, also the production of glass fiber reinforced plastics, which is used for construction, is declining. And that's the same for the transport sector. So there's we are developing similar to the general economic development in Europe and in the countries. So, and the application areas for glass fiber reinforced plastics are, as I already said, with a little more than 1/3 the construction and infrastructure sector, that's the blue field, and with also nearly 1/3 of the amount the transport sector. So transport is including all kinds of vehicles, cars, but also planes and ships and so on. And what we see in the last years is that these areas do not change very much. But meanwhile, the construction sector is a little bigger than the transport sector. And that is the first time, or it switched 2 years ago. So meanwhile, the construction and infrastructure sector for the use of glass fiber reinforced plastics is a little bigger than the transport sector. And then we have the sports and leisure sector and the sector of electronic goods made of glass fiber reinforced plastics. This figure differs, of course, a little bit with other materials. So for carbon fiber, it differs Most of the carbon fiber material is used for the aerospace and the production of planes and windmills, so that differs, but for GRP material, it's a little more than 1/3 for the construction sector and 1/3 for the transport sector. Yeah, and if we go more into detail, I won't explain you this table now in detail, but you see we have to divide the production referring to the different material classes. You see here in the first lines we have the production of SMC, BMC material. Michael already refers to this material class. Then we have the open mold techniques. This is hand lay up and spray up techniques. Then we have the RTM technology. Then we have the so-called continuous processing techniques, the production of sheets and the pultrusion process. And we have the production of pipes and tanks, either with filament winding or centrifugal casting processing techniques. And then we have GMT and LFT. So what you see here is the first processes, SMC, BMC, open mold, RTM, continuous processing, and pipes and tanks are all materials with a thermoset matrix. And the only thermoplastic material in our figures is LFT and GMT. So we are not having a closer look to all kinds of short fiber reinforced thermoplastics, which is of course also a very interesting and a very huge market. But our definition of the glass fiber reinforced plastics is all kinds of thermoset material reinforced with glass and thermoplastic material with long fibers, GMT and endless fiber reinforced thermoplastics. Yeah, and if we have now a look at the amount of production, you see that SMC BMC is still 1/4 of the production in Europe of glass fiber reinforced plastics. Still 21% is made with open mold techniques, so hand lay up and spray up. These are in each of the European countries the very small companies which are still working with non-automated processes, but who also produce parts and will produce parts in the next years. We have the RTM technique with 13%. We have continuous processing, pipes and tanks, and in the left corner at the bottom you see the amount of LFT and GFT material. And if we have a little closer look at the development of the thermoplastic material, LFT and GMT, Michael, can you switch to the next? Yeah, you see that in the last years, this kind of material was growing much faster than the rest of the GRP market. So the development of the thermoplastic material was very positive in the last years, but as you saw in my first figure, there was a decrease in 2020, and the biggest decrease was in the sectors which focus on the automotive industry, and that is SMC, BMC, and of course the thermoplastic material, LFT and GMT. But you see in this figure a development in the last 20 years from lower than 50,000 to meanwhile 150,000. So a strong increase in this market, because this material class is of course very interesting, especially for the automotive industry. Okay, in the next slide, you see the development of the different material and processing techniques classes. As I said before, you see, for example, the red dotted line are the open mold techniques. So 20 years ago, This material class was the biggest one in the production of glass fiber reinforced plastics with nearly 40%, and meanwhile it's down to 20%. So these are the non-automated production of the small companies. We have a really steady development of the SMC BMC market. You see it's in the last 20 years around 1/4 of the production volume, and you see, as I already told you, the very strong increase. This is the orange line of the thermoplastic materials, so LFT and GMT. So what we do when we have a look at the market, the one thing is having the figures, so the production volume, but on the other hand, we always ask our member companies, what do you think, how will the different processing technologies develop in future? Will they improve? Will they stay at the same level, or will they decrease? And what we saw in our last survey, asking our member companies about future developments, you see that many of the companies say that for especially the techniques Michael already mentioned, thermoplastic molding and combined processes with injection molding, so the two processing technologies at the right side. Many people say, or more of half the people, 54% say thermoplast molding will improve in the next years, and 2/3 of the companies, so 64%, say combined processes with injection molding will improve. But we also see that, for example, the pultrusion technology, nobody in the market says that this, it's of course a niche segment. It's a small segment with 50,000 tons production per year in Europe, but all our member companies say that this segment will improve or at least stay at the same level. And very positive views are also for the SMC BMC segment. 35% say that this segment will improve, not at least due to what Michael already mentioned, new developments of high performance SMC, for example. Okay, the next closer view we have to do is not only looking at the different processing techniques and applications, we also have to have a closer look at the different countries in Europe, because the development in each of the countries is very different. You see here that a little more than 10 years ago, the biggest country in terms of production of GRP material was the two countries, Spain and Portugal, with more than 250,000 tons. And even Italy was bigger in terms of production than Germany a little more than 10 years ago. But with the economic and finance crisis in the years 2008 and 2009, there was a very big decrease in the production volume, especially in the Southern Europe countries. And Germany didn't suffer so much in these times and stayed quite well. And you see that meanwhile, since a few years, Germany, this is the red line here, is the biggest country in Europe in terms of production of glass fiber reinforced plastics. And we had a decrease in all of the European countries this year, but the decrease was different. In Germany, we will have a decrease lower than 10%, and we will have a decrease of more than 15% in all of the Southern Europe countries, because of course the applications in these countries differ. We are very good in materials used for the transport sector in Germany, and the development, of course, is depending of the different applications in the different countries. And I think the last figure, or nearly the last figure, is also, that is already the last. That is another figure about the development in the countries. But figure I wanted to show you, maybe some of you or most of you know this picture. It's, I think, 4 weeks old. There was an accident with a train in the Netherlands, and the only thing that prevents this accident to become a catastrophe was that this figure, this whale, was made out of composites. And I think this picture shows very well what our material, the composites, are able to. So I would like to thank you very much for this short overview of the development of glass fiber reinforced plastics in Europe. And I'm open for all kinds of questions. Thank you very much. Do we have time for questions?
Yes, definitely. Thank you, Elmar and Michael, for the presentation. I have one question, actually 2 questions in the chat. First of all, Xavier asks if you can share your email address to him, maybe in the chat or after the call. I leave it up to you. Then there's another question of Xavier, I think directed more to Michael. Any other OEMs pushing for a composite introduction in high volume? So next to BMW, do you know any other OEMs who are pushing for composite materials?
Yeah, well, BMW, of course, was a pioneer for the carbon fiber, but composites in general, everybody is using composites, but on certain modules. So all OEMs, and especially the premium OEMs, are using composites. Think about the front end, the rear end, the doors, the roofs, etc., the seats. So it has to be just cost competitive. But all OEMs have active programs. SMC is very well established already, as you know. All of the BMWs and the Mercedes have a trunk lid that is made with composites due to the radio transparency that's needed there. Their flooring is an important area, so you cannot ignore a composite any longer, and especially if it comes to short fiber reinforced thermoplastic, there are several kilos. I think in total we have more than 250 kilograms of composites on each car on average.
Very interesting. So composites are everywhere. Maybe also have a question from my side. So 2020 have been quite a special year. We also saw it in the numbers. Did you maybe have some more detailed experiences how it happened during the year? Did the drop in composite sales happen in Q1, and did it bounce back in Q2? And what's now happening in Q4?
I will address these points in my next part of the last part of my presentation. So the impact of the COVID crisis, and you will see the numbers there.
Excellent. Thank you.
My presentation was not the end of our presentation. Michael still has one more point in the agenda.
Okay, excellent. We have one more questions in the chat. Maybe then we can still first do this question before we dive into the last one. What's the impact on repair strategies? Now BMW has a large number of vehicles on the road. Can they remain cost effective?
Yeah, well, it's a general question. I think, as you have seen maybe this weekend in Formula One on this heavy crash, what happens, etc. So in metal, you know, this car would not be there anymore. In composite, it survived the fire and it survived also the crash and saved the life. So of course, if they have a significant, severe impact and there's a crack, you will replace it, and that's maybe the cheapest solution to replace the door or replace the bumper or whatever whatsoever. But many, let's say, lower impacts, where you have maybe a dent in the aluminum, etc., would not happen in composites. Of course, there are certain repair technologies for the high-end supercars, you know, the Ferraris of the world. They're having a flying squad that will repair with some resins and carbon fiber pre-pregs the car, but mainly the repair technology is not the issue at the moment. I think there is a certain way of what you do on certain cracks, and if you have a significant crash and impact, you will replace the part.
Okay, thank you.
Okay.
Maybe also towards Teun, as has been presented by Bernard, this is also one of the demonstrators we will work on in the AACOMA project. So I would say stay tuned because a lot of the expertise partners working on the AACOMA project will further investigate also different type of methodologies and testings on how to repair composite panels.
Okay.
Good. So I leave the floor back to you, Michael, to continue.
Very good. So let me just close this presentation about the impact of the COVID-19 crisis. So I have maybe here only the year impact, and if you talk about quarters, so what happened specifically in the automotive industry was that as of April, or as of March 27, everything was standing still for 6 weeks. Nothing was produced, etc. And of course, it has an impact to the whole supply chain. Aerospace the same, etc. The biggest impact you saw actually around May and June. As you will see my numbers, there is a very nice recovery coming up as of end of September. And so the outlook is not bad. So I think the biggest impact was, as I said, the May-June timeframe. But it's different by region, by application, and market. So I will just highlight first, maybe in terms of the region. So you see here the impact, the volume drop or even increase versus last year. And when do I expect which year the recovery? So just think about, let's say, China. So China went first into the crisis already beginning of the year. China has just forecasted at least a growth of 3%. Also the industry, there was a composite industry event in September, and they have even increased prices of glass fiber because they did not have enough glass fiber at that time. So the industry picked up. So they're expecting for maybe 3% growth. Of course, this is not the growth that they had in the past. Last year they had 7-8%, and before maybe 10% in the composite industry. But China basically will have growth versus last year, so their recovery is already happening. In Europe, we foresee as an industry, as also Elmar has indicated already, around 10% across the board, thermoplastic, thermoset, and maybe throughout the year 2021 we have to build up the volumes, but by 2022 we should see the volumes that we had before the crisis. The good news is really, I spoke to many companies in the last couple of weeks. We had also several board meetings. So the statistics are showing that the market is coming back very nicely at end of September. And the months of November was very good, and also December. Many companies have only a very short closure, only a few days between the holidays to cover up, and also the outlook of January and February is already very good. So they have good orders in place. If we are completing this picture now with the USA, so USA is deeper in the crisis, as you know. The outlook here is maybe minus 15% to the composite industry, but also recovery around 2022. If you look, of course, into market segments, there will be significant differences. The biggest impact was to aerospace. So aerospace volumes are down 60%. Big impact to Boeing and Airbus. You have seen all the numbers. All the airlines are suffering a lot. Some airlines, like South African Airways, basically closed operations, etc. The announcement of the CEO of, I think, Lufthansa was maybe 2025, 2026. We might back to the numbers that we have seen so far. But you have to differentiate that. So I think cargo will come up again big. Let's say, I would say travel for vacation will also come back maybe a little bit sooner. But of course, international business travel with expensive business and first class tickets, etc. This will never come back, I think, and will be in a different way. So aerospace is impacted a lot. I'm working with several clients in the aerospace industry. What we see is also there's a difference by region and also by aircraft type. For example, China is heavily investing in aerospace. China itself, they need a lot of airplanes just for the local or for the regional transportation. They have more than 100 cities with more than 1 million people of inhabitants, and they need aircraft. So the Airbus 320 type or Boeing 737, and they are developing 2 aircraft addressing this market, and they have full order books. And also certain suppliers from Europe and America into that market will benefit from that. So in terms of aircraft, of course, you have heard about the Airbus 380 will not be continued. And the large aircraft, I think, will have a slowdown because there are just too many aircrafts. Lufthansa is shutting down more than 150 large aircraft forever. But the regional jets, small jets, going with one jet to the final destination, that's growing very, very well. So let's say companies like Dassault and Bombardier are doing fine. And so it's definitely the most impacted business, aerospace, and I think this has a long way to go. And maybe we'll see also some trends. Airbus has announced also new engines, fuel cell driven engines by 2035. So they're working maybe a next generation here on a better CO2 footprint for the airplanes. Automotive, around 20, maybe only 15% by the end of this year. I think the last numbers are improving a lot. Also automotive, a big difference. The German premium automotive brands are doing quite good. They have good order books. If you want to buy now a BMW, Mercedes or Audi, you have to wait almost a year. For many cars, the traditional cars, the normal cars, maybe a second or third car, a small, let's say a Fiat, Peugeot, etc. They are more impacted in Germany, and you have the model of company cars. You have a lot of lease contracts, and they continue, and therefore the outlook is not looking bad. And the range of models, including the plug-in hybrids and the electric vehicles, is increasing a lot, and maybe there's a change going on. So I think the outlook for 2021 and 22 is not looking too bad. Infrastructure did not decline in the crisis. You can see it everywhere. Construction is going on in Europe, so it did not decline, and so as well as consumer goods. So consumer goods, also people invested into not only bicycle frames, surfboards or whatsoever, but a lot of outdoor activities, a lot of electronic activities, a lot of home offices to be installed, etc. So that is also suffering. Energy, electrical, wind energy, for example, that has not too much to do with the crisis. It's more the transition and the availability of new spots for wind turbine, etc. Will come back also next year. So in terms of the market, you have seen that, and that translates then into materials. So thermoplastics suffered less than thermoset, as you have Elmar's numbers, but since some products did quite good, SMC, for example, is surprisingly doing well. It has to do with the truck industry. A big element is the truck industry, which came back very nicely now due to more, I don't know, Amazon shipments of goods to the people, etc. So small and large trucks are used more. Recreation vehicles are used more. Motorhomes, etc. Using maybe a roof from SMC, etc. Doing well. And on thermoplastic side, I think GMT, LFT, and also now tape-based products are doing okay, and should come back in next year or the year after. And what did this COVID-19 do to us? So I think life will be different after COVID-19. It will not be the same. We can see it here, for example, in terms of what we are doing. So we do a Zoom and video conferencing. Everybody had to do it from one day to the other. I remember the last company visit I did in March 13 to Airbus, and then next day we had to do Zoom meetings with everybody. And so I think video conferencing is a big winner and a very efficient. And we have this meeting here today by video conferencing, a very cost efficient, time efficient system that everybody can use. Travel, I think travel will definitely change. I mentioned that already. International continental travel will maybe cut in half in the future. not just for a big meeting going maybe to America or China, but maybe once a year, and going to a trade show and being more focused on, let's say, video conferencing and maybe phone conferencing. Definitely personal meetings that we are suffering a lot. This will be a little bit less and maybe we use the other tools, but will be remaining very important. I think important is also the trade shows. People are suffering that they cannot meet at trade shows. So definitely large trade shows like the JEC or composites for China are very, very important, and everybody will go there. On smaller regional trade shows or focusing on only one specific subject, that will be less. We will see that. We have heard that also composites for Europe, the trade show will not continue next year, but there is already maybe a plan for an alternative coming up, because in this field the DACH region, Germany, Switzerland and Austria are too important to the industry. But we will see here a change as well. But the personal meetings, the meeting at trade shows will be important. Closing deals, you cannot do this by video conferencing, or very difficult. You have to have personal visits. Luckily, we have a lot of tools developed in the meantime, and also now we have the vaccines coming up shortly. So hopefully 2021 we get this crisis behind us. So that's basically from the COVID impact from my point of view. So let me summarize Elmar's and my presentation. So important that you heard also from the previous speaker, Bernard, is we want to position the EMR region in the three-country corner here as a hotspot for future for composites, automotive, e-mobility. And I think we have all the tools and elements and capabilities here. AACOMA project had just started. We have a nice, let's say, organization around the advisory board. We have demonstrators, and we have roadshows and events organized. I have highlighted the trends in the automotive market. So robust, cost-efficient processes are needed, automated processes. The COVID crisis, we have highlighted the impact, and it's coming back now, I would say, nicely. Aerospace, we have to watch. The last quarter of this year is looking already promising if you talk to the raw material producers, etc., and also to the OEMs, and so we should get out of it. And our day-to-day life, as I mentioned already, will be different, but we are all looking forward to meet everybody in person and meet everybody in person soon. So that's basically the end of my presentation, and I think Elmar and myself, we are up for additional questions.
Thank you very much for this presentation, Michael and Elmar. We don't have any very specific questions in the list. There is one remark from Martin that indeed repairing of composite structures is a major issue, and DCMC focus on this issue, and they are looking to reach out to the AACOMA partners to see if we can connect. And as I also already mentioned earlier, Martin, there will be a demonstrator on composite repair. So making these demonstrators, we will of course look at the state of the art and the difficulties sometimes, or the challenges to these specific demonstrators, and also on composite repair. So we would very much like to get in contact with you, and we will do so to get into the details, to make the demonstrator even more relevant and make the research we are doing relevant for the broader industry.
Yeah, and you have here also our contact detail. I think someone asked for the details here. So the presentation will be made available after today. Will be circulated through Flanders Make, and you can see here already our contact information, our emails, web pages, telephone numbers.
Excellent, thank you. So that's it for today. We are also almost out of time. I don't see any other questions. I still leave room to add your question if you want in a couple of minutes. But also tomorrow we have a very exciting agenda where we will have a session about manufacturing and assembly of composite parts made by Cirrus and Flanders Make. And afterwards we will have a matchmaking event, as I mentioned in the beginning of the the Roadshow today. And during a matchmaking event, I believe you can discover who else, what kind of other companies are present in the region Maas-Rhine. And we see also what kind of challenges and what kind of, we can have an open discussion about the challenges and the trends within the composite industry. Good.
Okay. Thank you very much.
Thank you very much.
Have a good day.
Thank you as well, everybody, for joining.
Thank you.
Bye.
Bye-bye.